So now let's take a look at carbon. And we've looked at the basic properties of bonds. And interestingly, carbon has 6 protons. That's what makes it carbon. So let's take a look at what 6 protons looks like. So again, that means I'm not going to write it, but you're just going to know that for 2 electrons, how many electrons do I need to fill in to make this atom neutral? 6. So I'm going to fit 2 in the first shell. And then in the second shell, I'm going to put how many? 4. That's correct. Again, there'll be 2 in the S and then 2 in the P. So there's my 4. Now, if I can simplify this, I'm going to make it simple. And the problem making it too simple, not reminding you of what's going on inside, is that sometimes we leave things out of our brains. So I always think it's important to look behind the curtain before we start putting on the show. All right, so what we can do, someone close the door, please, unless there's someone out there that needs to come back in. So we can redraw this atom with just dots. Let's keep it simple. Carbon, and let's just put the dots representing the electrons in the outer shell. How many dots would I have?
6.
4. I heard 6, I heard 2, and I heard 4. The outer shell, 1, 2, 3, 4. Outer shell. Inner shell, 2. Outer shell, 4. Total, 6. All right, so there's carbon. Now, why is carbon so interesting, and why is all life on Earth carbon-based, not bast, life forms? Because of the at least one interesting thing about carbon is that it can form 4 bonds. So it can go in 4 different directions. Where if you used oxygen as the base, 1, it's fairly reactive, and 2, it's going to go in 2 directions. So this increases the number of shapes. Shapes, for you artists out there, in biology, shapes are incredibly important. You will not understand the shapes that we're looking at. When you're looking at the shapes of a protein, it's crazy folds and shapes. Hemoglobin is distinctive, but there are many shapes that you do not have to memorize the shapes, but you do have to realize that. So what I would do if I were gonna do what I'd like to do, which I think I am gonna do, is I'm gonna do a spot check on your notebook right in a minute. I'm gonna come around and see who wrote down the main idea that I just said and who didn't. No, if I said it again, it would defeat the purpose.
Was it shapes of our forehead? Oh, she got you.
No, she was listening. I could tell she was listening. I wasn't trying to get her.
Man, you know dang well she was not.
I was literally looking dead at her, and she was looking up at the screen. Like, I don't understand that. So anyways, shapes are important. Shapes define the function. So there are some keys to biology, like there's keys to chemistry. And one of the keys to biology is that structure, that's shape, helps define function. Now, this is an intuitive idea. This makes sense. There's a reason why doors are rectangles. There's a reason why windows are rectangles. Round doors don't make sense to us because they don't work that well. They're pretty, like the Hobbit doors are round, they're nice, but they don't really work that well. So there's a reason houses have 4 walls, because they work that way. And so when you're talking about structure and function, once you start to get into this is one of the key ideas. You have to remember that those 2 are intricately linked. So the shape of something is going to determine how it functions. Wheels are round, they're not square. square wheels would not work very well. All right, so keys, structure and function. So let's take a look at why carbon, what determines carbon. Carbon, you can take and link. One carbon can be linked to another carbon, can be linked to another carbon. All of them sharing electrons. Why? To fill their outer shell. But you don't have to bond them just to carbon. They can form chains, and that's really great. You can also bond them to other things like oxygen. Like, for instance, what if this is a carbon here, and there's an oxygen, and it needs two bonds, so that's bonded to hydrogen, and then this carbon here is bonded to a phosphate group, let's say, another carbon that's bonded to a phosphate group. Phosphate, I'm going to draw it like this. Phosphate is a symbol, it's a name for a species that's defined as phosphorus with 4 oxygens around it. And that's what we call phosphate. So when you see a P with a circle around it or the word phosphate, they don't mean phosphorus, they mean an oxygen. 4 oxygen around a phosphorus. And then you can have this, and each one of these can have a carbon. You have something like this going on. Huh?
Can we just do like a simplified version of this?
This is actually a thing, yeah. This is actually a thing. I'm sorry. I'm just going to put, instead of an actual symbol, I'm going to go ahead and put something like this. There's something's attached to it. And then so this would be an example. This would be an example of something called a triglyceride. Triglyceride. You have this in your blood. When you go to doctors, they measure this. They measure this in your blood to see how healthy you are. They want to know how many triglycerides do you have, what percentage of your blood's made of triglycerides. Because this is how you transport fat in your bloodstream. Fat is not soluble in water. You know that oil and water don't mix. They sit on the top. How do you take your fat that you eat from the inside your intestines and put it and take it to all the cells of your body? You have to have a way to transport that. So triglycerides are really important. This is something called glyceraldehyde. 3-carbon molecule. This is going to be important later. This is an important species here that we put together. It's the backbone of triglycerides. Is glyceraldehyde, right? It's a glycerol. Now, these also have oxygens on them. These aren't very accurately drawn. I apologize for that. You'll see them better drawn in the books. They're more specific. But what the point of me drawing here, that what I've drawn is a skeleton, is to say that there's this long chain of carbons. When you have a long chain of carbons, we call those lipids. Those are lipids, long chains of carbons, period. Now, there are other forms of lipids that form chains. Some of those things are known as, they can be steroids, and they are steroids. Steroids are also lipids, but lipids are also fats, which include fatty acids. These chains, these triglycerides, are made of fatty acids. These 3 things here, each one's a fatty acid. Now, there's 2 kinds of fatty acids. There's the saturated fatty acids. All of you have taken health, is that right? Well, you've all taken biology, so I know that we covered in biology. Saturated and unsaturated. You'll be learning about this in health as well. Saturated and unsaturated fatty acids are important.
What about like trans-saturated everything?
Trans is a little different. There's also a third kind, it's called trans. Trans are formed during specific conditions. These are health-wise, these are probably the danger. It's likely that so far as I know, unsaturated and saturated fatty acids are good for you in different concentrations. Okay, you're here to heat up your food?
Yes.
You heat up the water in the kettle and pour it into your ramen noodles.
These ones you could put them in there.
All right,
The other ones you can't do that.
All right, do it this way, it's better, it's safer for you. Heat up the water, then you can all pour your water at the same
We
time.
already heat up our stuff, it's just hers.
Oh, okay, all right. Yeah, what did you pour, water in there?
Yes, water in it.
All right, microwave it then. Don't microwave. Do not trust corporations. Do not microwave plastics or papers covered in plastic. All right, just don't do it. No, it's not too late. We call it, let me pause. All right, so trans, unsaturated, saturated. Now with saturated fatty acids, what they mean is every time you have these carbons, often what you'll see in the drawings in the book and in class is you'll see a bunch of a carbon chain drawn like this. They generally don't like to draw the hydrogens because they want to make it easier. But in an attempt to make it easier, what happens is that it becomes more confusing. So they really are trying to make it easier. So every carbon, remember, has to have 4 bonds. That's what we started this whole conversation with. Every carbon has 4 bonds, period. So let's think about it. If this has 4 bonds, what other things are connected to it? We're going to show all the carbons are shown. What else is going to be connected? Hydrogen and possibly oxygen, possibly phosphate. Correct. But let's go ahead and let's just talk about just hydrogen. Let's put it in green for this case. Imagine me putting all these hydrogens in this. That's a lot of work, don't you think? Every time I draw a biomolecule, I'd have to draw 100 hydrogens. That's insanity. Do you agree that nobody wants to do that? Does anybody want to draw hydrogens every time? It just would take too long. So we came up with a shortcut. We said, look, when we're drawing these things, let's not draw all the hydrogens because there's too many of them. Is that fair? So we'll just draw the carbons and if necessary, the oxygens, or the phosphates, if there's a phosphate attached. So we'll draw the carbon chain. So if this is, do you see how this has all single bonds? That means every bond is either bonded to a carbon or it's bonded to a hydrogen. We call this a saturated fatty acid. That's saturated. That means that every bond is either to a carbon or a hydrogen. There's a single bond to everything. There's no double bonds. Now, once you get a double bond, once a carbon has a single double bond, now you have a what? Unsaturated is correct. See how not hard this is? And this one, what if I had 2 double bonds? It would still be unsaturated, is correct. But because it's more than 1 double bond, we call it polyunsaturated. And you'll hear people talk about this, I think, less than they used to. All right, because today we know that saturated fatty acids aren't that bad as long as they're as long as you're eating a limited amount. You don't want to eat mostly butter and animal fat. It's just not a good idea. But having mostly polyunsaturated fats in your diet, having some saturated fats, really good for you.
Is polysaturated only two bonds, or it can be
Two or more double bonds in the chain. This is the chain. We're talking about one chain. I didn't draw any of the hydrogens because we all agreed that would be a pain. All right. So that's polyunsaturated and saturated and unsaturated and saturated. All right. There are consequences of these bonds. These bonds are shorter than these bonds. And because these bonds are shorter than these bonds, here's what happens to them. When you have a double bond, when you have an unsaturated bond, you have a double bond, there's a kink to the chain. The chain turns. That changes its function. It doesn't work the same way as one that has only single bonds. Same number of carbons in a single bonded format. Do you see the difference? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think you can see that there's a big difference between this and this. This bend in the chain makes a big difference in the lipids. And remember what a phospholipid is. There's another lipid that we've talked about that I'm sure you remember us talking about. And we draw it generally with a phosphate head. It's more complicated than just phosphate. It has other parts to it. Because it's this glycerol molecule. It's a triglyceride. You see here? But it starts off with the glyceraldehyde or the glycerol. All right, it has a glycerol on it. But one of the fats in the glycerol chain is replaced with a phosphate. So you have 3 parts. Phosphate, actually 4 parts. A 3-carbon chain known as glycerol. Right? It's an alcohol. You have 2 fatty acids and a phosphate. So 4 things, or 3 things, depending on how if you call the fatty acids 1 thing or 2. So you have 4 parts to a phospholipid. So a phospholipid is obviously you have a phosphate attached to the glycerol, the carbon of the glycerol. Then to the other 2, what do you have?
hydrogen.
Carbon chains. It's a phospholipid. What's a lipid? It's a fat, but what's a lipid? A chain of carbons. So if you have a chain of carbons, there's 1 phosphate, a glycerol, and 2 fatty acids, 2 chains of carbons. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. I guess I shouldn't draw it that way. 5, 6. Again, I'm not drawing the oxygens or the hydrogens right now. I'm just focusing on structure and function, structure and function.
So what's it called?
This is called what? Who remembers what this is? What is this thing called? These lipids with a phosphate? Phospholipid. So if you eat a lot of polyunsaturated fats or unsaturated fats, what you end up with is a lipid. The cells of your body, the cells in the blood vessels of your body have this structure, kink in it. The kink is important. These fatty acids are actually longer. They're like 20 carbons long. I'm not drawing all that. So you're seriously literally watching a video right in front of me when I'm teaching you the structure and function of phospholipids? No. Don't tell me you're listening to everything I say. Don't say that. Just please don't say that. Come on. Put the thing away. I'm not going to keep chasing after you. You're too old. Yeah, my phone rang and I hung it up. And if it's important, I'll pick it up. That's right. And if it's important, you can step outside and you can talk to your parent or whoever, your boss or whoever. But sitting there giggling about some video, TikTok or whatever, is not appropriate, man. Come on. 2 phospholipids. One has an unsaturated bond. The other 2 have saturated bonds. If your lipids, the cells of your body, are made mostly of this, then they can stack. They stack. And so when you're looking at this, because they can get real close to one another. And because they can get real close to one another, they can form structures that clog your arteries. Does that make sense? Where if you had a bunch of this makes the membrane more fluid. It keeps your blood, your cells, your tissues much more fluid. Because they have a kink, it requires more space in between the molecules. You can see that in the same space you have less fat, and that allows the membrane to be much more of when you're using these building blocks to build a membrane, your membrane is much more fluid, it's flexible, it's not as brittle, doesn't form as many clumps, and so your blood flow is much better, right? And it tends to be a healthier result. So when we talk about saturated fatty acids and eating more or less of them, what you want is a mixture of these 2 in your blood. This is very helpful in the wintertime. In the summertime when it's hot. It keeps your membranes together. This is very helpful in the winter. It helps stop the membrane from freezing. In fact, animals, you'll have more steroids, more cholesterol, which is another lipid, in your membranes in the winter than you do in the summer, because the cholesterol, along with unsaturated bonds in the fatty acids, help keep the membranes fluid, help stop your cells from freezing and breaking. This is much more brittle. A membrane made of these is much more brittle, much stiffer. All right. So some main ideas is the difference, the connection between structure and function. Remember, we have to turn in Cornell notes. Structure and function. Okay. Come on. Okay. Wow. Okay. This keeps jamming. All right, structure and function. And you also have to consider another main idea is fatty acids. Lipids in general. Maybe I should move this around, huh? Seems kind of... Lipids in structure and function, lipids in general. Lipids like cholesterol. Lipids are made mostly of carbon. That's another detail that we should make sure you understood. When you're looking at lipids, they're mostly carbon. And even though they're mostly carbon, they do have some other elements in them. They can have lipids, first of all, will have carbon, that's for sure. They likely will have oxygen, but not that much. They certainly, let me not put oxygen next. Say what? What'd you say? Huh? Carbon, hydrogen, mainly carbon and hydrogen is a lipid.
I remember the thing, but I can't think of it.
I know, schnapps, yeah, that's right. SNOPS is the total for all the elements of life, but for lipids specifically, when you're looking at a molecule, you're thinking, is this a lipid, a protein, a carbohydrate? What is this I'm looking at? If it's mostly carbon and hydrogen, you're dealing with a lipid, probably. There's likely some oxygen, but less than in other molecules. Sometimes there certainly can be phosphorus. Certainly can be phosphorus, phosphate specifically. And there's maybe some other elements in there, but when you're talking about lipids, these are the ones you have to concern yourself with. If you see mostly this stuff, then you know you're dealing with a lipid. Structure and function. Lipids are hydrophobic. That means they don't like water. Period. This should all be a review. It should have been in chapter 2. Fatty acids can be saturated or unsaturated. It's messy. I should rewrite it, or you got it? I'll rewrite it. Saturated or unsaturated. So fatty acids can be saturated or unsaturated. They're hydrophobic, all right? And they arrange themselves in such fashion. So hydrophobic things, remember, like dissolves like. I don't know if you remember that. But like dissolves like. If you thought about it, it would make sense. You know that oil and water don't mix. If you want to dissolve nail polish, you need acetone. They're both hydrophobic. Like dissolves like. So these are lipids. That's it. That's a short run on lipids. We're going to go into more detail as we go along. These are fatty acids. These are saturated and unsaturated fatty acids. We know we have cholesterol as one example. We also have things, there are steroids. Steroids are also lipids. They're lipid soluble. They are lipids themselves. So that is. Where am I? Dissolve. Sorry. My spelling is not my strong. This thing keeps jamming.
Okay, Mr.
I wish it would. Like dissolves like. Hydrophobic, correct? Are we good with the spelling? Good with the ideas? We know what we have to know. You have to know this. You don't know this, it's going to be hard for you to understand anything that we draw in the future. So this is just lipids. Lipids are probably the easiest of the biomolecules to identify, the easiest to draw. Now, how much time do we have left in class? Somebody know? 20 minutes, excellent. Wait, 3 minutes or 20 minutes? 20 minutes. 20 minutes. Oh. I mean, if you guys want to skip it, we can just go right to the test, and then we can move on to the next. If this is boring anybody, I don't want to go over material you already know. If you know it already, you're solid, I got the test printed, I just pull out the biomolecule test, you take it, we move on. Honestly, I don't want to do anything that bothers you. I'm not saying that as like some kind of game or anything. I got no problem with giving you a test now and moving on to the next topic. Not an issue.
Can you assign us like lessons on AP Classroom, like quizzes and things?
I will. I am going to sign them to you next week. Yeah, I was planning on it. But this week, you guys have had your videos, and you had a quiz already assigned to you. You should have finished that by now in AP Classroom. Next week, you're going to have assessments, not more videos. You're going to have quizzes and assignments due in AP Classroom. Really? You think that's too much for you?
Jesus Christ.
May God forgive you for using his name in vain for such a silly thing. Such a silly thing. Like this isn't like even a shock. It's like not even that doesn't even deserve an oh my gosh. Let it go, go right to the J man. All right.
I don't even know why you pay me anything.
Because you're my student and I care about you and I want you. I seriously, as silly as that is, I really care about you. If I didn't care, let me tell you something. I've been there. I've gotten to the point where I'm like, okay, I don't even care anymore. I'm just going to teach and whatever. It gets to a point where you have to say I don't care anymore because otherwise you go crazy. It of course I care about every one of you. You're watching TikToks while I'm explaining something that's basic. It's going to be an issue. It has to be an issue. I'm not doing my job if I don't bring it up. All right, so last 20 minutes, what I want you to do is this. I want you to make sure that your trays are full of water. We talked about this. Make sure that all your trays all the trays, not just yours, the 9th graders as well, 9th and 10th graders as well. Make sure all the trays are not full all the way up, but full to above the holes of distilled water. Make sure that you have 5 extra seeds in each one of your pots from the new bag of seeds. And make sure that you've watered your plants with the appropriate salt concentrations. And lastly, if you want, move your tray near a windowsill and out of the light if you'd like, so that we don't have to worry about the length of time these things are exposed to sunlight. In fact, could you turn on the lights so that I can turn them off on the way out? And that'll wrap up today. All right. Now, so as you take a look at this and you look at a fatty acid, as we discussed earlier, a fatty acid is basically, and I think this is a much better drawing, a long chain of carbons, mostly carbon and hydrogen. I don't think anyone could argue that this is not mostly carbon and hydrogen. This is mostly carbon and hydrogen. Am I clear on what I'm saying here? Okay. So you have mostly carbon here, and then surrounding it, you have hydrogen. Notice that all the bonds have single bonds. Either they're bonded to a carbon or they're bonded to a hydrogen. So we call this a saturated fatty acid. It's a fat because it's carbon and hydrogen. It's an acid because of the carboxylic acid group. So one of the functional groups that you have to start learning is this C double bond OH. We call it a carboxylic acid. It can be drawn in a number of ways. As you can see there, it could be a C. You can have a C double bond oxygen, single bond oxygen, H. Remembering that each oxygen needs 2 bonds. So you see there's 2 bonds to this carbon. This oxygen has 1 bond to this hydrogen, and 1 bond to this carbon. So we don't necessarily, often what's left out of a drawing like this is the line in between the oxygen and the hydrogen. They just put OH. How many bonds does carbon make? 4. That's correct. There are 3 shown here. You need to write the 4th because that's what's used to attach it to the chain. A lot of you have those little bracelets, those charm bracelets. Each charm bracelet is linked to, each charm is linked to the bracelet by a link. These links in a molecule are called covalent bonds. This is a carboxylic acid group. You must be able to identify it. You will see it again and again. It's one of the main functional groups. As part of this group, there is another group called hydroxide. We will add to our vocabulary as we go along. Does anybody by any chance remember what hydroxide looks like?
One hydrogen, one oxygen.
That's right. It's an OH. Now again, we're not drawing the bond between the O and the H, but this hydroxide could be attached to anything. It could be attached to this carbon, and then this double bond O could make this a carboxylic acid, or it could be attached to another hydrogen, which would make it what? Water, or what have you. So this is hydroxide. Also very common in biochemistry. When we look at a molecule like this, it's a long chain of carbons. That's the fat. This is the carboxylic acid. That's the acid. So this is a fatty acid. Now we can take a fatty acid and we could attach it. We could take 3 of them and attach it to a glycerol molecule. So let's take a look at a glycerol molecule. All alcohols end in OL, like ethanol, isopropanol. They all end with this group of letters called OL, right? Not called, but OL. This is glycerol. It's an alcohol. It's a type of alcohol. You know there's different kinds of alcohols, correct? Right? There's ethanol, which people drink when diluted enough. There's isopropanol that would be poisonous if you drank it. There's methanol, which is poisonous if you drink it. All alcohols are poisonous. You shouldn't, don't think, just ethanol is, you can tolerate it more. So you can get drunk. By the way, drunkenness is a level of your body being poisoned. So when you're drunk, those are symptoms of you being poisoned. Acute alcohol poisoning can lead to death. And many a college student has died that way. So be careful with alcohol. It's not a joke. It is a drug. So this is an alcohol that's known as glycerol. 3 carbons, 3 OHs. This glycerol molecule, we're going to use it a lot in biology. So make sure you're aware of what it looks like. If you are aware of what these little components look like, it will make the rest of your year that much simpler. I debated, and in fact, Chardon and I discussed it on whether I should have had you memorize it over the summer. I felt like you had enough to do over the summer. So did Chardon. Chardon agreed. It seemed like most of you wouldn't do it anyways. So it wouldn't have made a lot of sense to assign it. Even if you did it and you're the only one that did it, then the rest of the class, you'd have to sit through it all over again. So learning these are important. For some of you are going away next week to college visits, I'll make sure to have that list of things for you to work on while you're on the bus, since you'll have many hours bus ride ahead of you. I'm assuming you're taking buses. So we could take this alcohol, and what's interesting about the OH, what do you know of OH? We just talked about hydroxide. This is a hydroxide group. You see it? OH, 3 hydroxide groups on a carbon chain. All right. By the way, that's what makes an alcohol is hydroxides. So you have an OH group. What do you know about hydroxides? OH, what could you attach to it? A hydrogen to make water. So we can do a process called dehydration synthesis. If I use the word synthesis, what does that mean to you? Make is correct. If I use the word dehydration, what does that mean to you? Taking out water. Very good. I like some of your thinking, though. You weren't too far off. So we're going to take water out. So the objective, what we're looking at now, is called dehydration synthesis. Synthesis, again, means making. Dehydration, you're taking water out. Well, here's a fatty acid. There's that long chain of carbon and hydrogens. It's saturated. Do you agree? All right. And then you have a double bond OH. What do we call this? That's hydroxide. What do we call this whole thing? Carboxylic acid. Correct? So we have a carboxylic acid. There's a hydroxide group over here on alcohol. What do you think is going to happen between this OH and this H in dehydration synthesis? Yeah.
You're going to take out 1 O and 2 hydrogen.
That's right. This whole group is going to leave with this hydrogen, and that's going to form water. This OH and this H are going to leave, and that's going to form H2O. But then that leaves you with an oxygen that has an extra electron, correct? Because you only took the hydrogen here. And then leaves a carbon missing a bond. Do you see that? The oxygen is going to miss a bond. The carbon is missing a bond. Carbon must have 4 bonds. Period. There's no exception in biochemistry for the most part. So carbon has to have 4 bonds. Oxygen has to have 2, or there has to be a negative on it somewhere. So it used to have 2 here, 1, and then the second one be with the hydrogen, but the hydrogen left. This one had 4, 1, 2, 3, 4, but the hydroxide left. So now you only have 3. How do you fix that? Bond those 2 together. Hence the word synthesis. We're putting them together. So the dehydration is us removing water. The synthesis is putting them together. So by taking water out, we're able to add to each of these 3 carbons a long chain of carbons and hydrogens. Is that clear? So then we have a triglycerol, or triglyceride, or however you want to. There's a difference in the chemistry. It's irrelevant. The point is 3 fatty acids attached to a glycerol molecule. Are we good with that?
I actually have a question.
Yes, excellent. Go, ask your question.
Okay, so you see like the fatty acid at the top, how like it's very like straight, but then when it gets to be triglycerol, it like kind of is like a slant.
Yeah, that's a really good question. They're just 2 different ways of drawing it. So that's really a good catch there, Rachel. This long chain is just drawn differently. This is more appropriately what it looks like. It's trying to give you some inkling of what it would look like in 3 dimensions. But no, there's no real, they're the same. They're just alternating the bonds, so the angle of the bonds. Is that fair?
Yeah.
So they're just 2 different ways of drawing it. But you're right, it might have been important, but in this case, it's just a matter of representation. Are we good with that? Now here's a quiz. Here's your quiz question. Take out a sheet of paper. Blank sheet of paper.
Are we like doing them 1, 2?
A single sheet of paper. You have 1 question. Put everything else away. You don't have to put it away. Just hide everything else. If I see any information out, you have a 0. If I catch you copying off someone, you both have negative 100 points. It's a 100-point question. 100-point question. It's actually a 2-parter. Close your computers. Nice computer, by the way. Nice computer. Close your computer. I'm recording it for anybody who's absent. Make sure you all that material gets put away. It's just you. You and your brain. If you're sitting around someone and they copy off of you, you know you both have negative scores, right? I don't want to hear it that they copied off me. I'm not listening to it. So you're making choices. Didn't I ask you to leave? To move. I asked you to move for a reason. All right. I don't want to ask again, though, okay? All right, so first part of the question is how many fatty acids do you see here? Number them from top to bottom or left to right, however you see them. How many fatty acids? And the second question is, are they saturated, unsaturated, or trans? That's your quiz. How many fatty acids do you see there? And are they saturated, unsaturated, or trans? If you're paying attention, you know the answer is easy. And I recorded the question so you can go back and look at the video and see how easy it is. I literally just walked you through the answer. How many fatty acids? That's a number. It says write a number. And then are they saturated, unsaturated, or trans? That's a word. One of those three words. Write it down. Make sure your name's at the top. Another 30 seconds, and we'll pass in a minute. All right, pass them in. Pass them to me, please. Quickly so I can go over the answers and we can keep going. Hopefully it's 100% for everybody. Thank you. Thank you. Thank you. Thank you. Thank you. Is that everybody's? All right, excellent. So if you look, there's 3 fatty acids. There's one. It's a fat, long chain of carbon and hydrogen. 1, 2, 3. 3 fatty acids. That's why we call this whole molecule a triglyceride. And notice that there are no double bonds. So they're saturated. All 3 are saturated. So easy peasy, lemon squeezy. That's okay if you messed up. It's a quiz. It's 100 points. Not the end of the world. There'll be many quizzes left. There'll be many quizzes all year long. It will not impact your grade if you mess up 1 or 2. Huh? Yeah. 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 You have an activity, though, that is due at the end of the day.
Is it, should we go ahead and start on this?
I wanted to touch on some of the details, help you out with the answers. So you have structural formulas that we don't just, so you just saw a triglyceride. That's 3 fatty acids attached to a glycerol molecule. We could take that glycerol molecule, which, by the way, we do all the time. Glycerol is used all over the place as a structural component of different molecules. Instead of adding 3 fatty acids, we could take that fatty acid and take it, move it out of there, and instead add a phosphate group. Do you see the phosphate? There's some nitrogen in there as well, but this is called a This is a phospho head, so it's a phospholipid. There's the 2 fatty acids with a phosphate head. There's phosphate is the main component, but there are other components to the molecule. So when you see hydrophilic head pointing out there with two tails. This is what it represents. Do you have to memorize it? No. How do we put it together? Dehydration synthesis. By the way, we made water when we put them together. What do you think happens when we break them apart?
Hydration synthesis.
Good, not synthesis.
Hydrolysis.
Hydrolysis. Lysis means break apart. Lysis means break apart. So let me write it down just so you know. Hydrolysis is the opposite. Hydrolysis is breaking apart. So dehydration synthesis is putting together. Hydrolysis is breaking apart. You're going to put water in, and then the bonds separate. Hydrogen takes one of the bonds. The hydroxide takes the other bond. As you can see here, you took that triglyceride and you kicked out the carboxylic acid again. This got kicked out. And then it was used, then phosphate took over that third bond. You see 1, 2, 3. This is the glycerol molecule. Do you see it? 1, 2, 3. 3 carbons. This carbon's attached to phosphate. The carboxylic acid got kicked out with its fatty acid. So the fatty acid got kicked out and the phosphate head took over. All right. So that's the basic biochemistry of phospholipids and basic lipid structure. I believe